Hey guys, Joe back at it once again with some OCR FSMQ past papers, and today we have the June 2014 examination paper. If you've missed any of the previous papers that I've done, they're in a playlist on the channel, and yeah, you might notice a bit higher quality audio because I've got my new mic, so hopefully you guys will notice that. You might be able to hear other things as well, such as cars outside, but we'll cross that bridge when we come to it. But without further ado, let's get into the paper. So, question 1, solve the following. This is very similar to a question a couple of years ago on the paper. Minus 6 is less than 2x minus 1, which is less than 7. Obviously, you just split it up into two separate questions. 2x minus 1 is greater than minus 6. Take the minus 1 over the other side, divide both sides by 2, so x must be greater than minus 5 over 2. And then on the other side we've got 2x minus 1 must be less than 7. Take the 1 over the other side, you get 2x is less than 8. Divide both sides by 2, x must be less than 4. And there you go. So minus 5 over 2 must be less than x, which must be less than 4. So there you go. That is question 1 done. Question 2 then, the gradient function of a curve that passes through the point 1, 2 is given by dy dx equals 3x squared minus 4x plus 7. Find the equation of the curve. So, if we're given it in this format, we need to integrate it back to get the original equation. So, you integrate 3x squared minus 4x plus 7 with respect to x. Add 1 to the power, divide by the new power. So you end up with that, because obviously 3 goes into 3 once, so that's a 1x cubed. 4 goes into 2 times, so we'll call it minus 2x squared, plus 7x plus c. And we've been given a coordinate as well to finish off the equation. So we know that when x equals 1, y equals 2, therefore we'll replace the numbers like that. So therefore a c is a minus 4. Put that back in for the examiner and call your curve y equals x cubed minus 2x squared plus 7x minus 4. You've got yourself another 4 marks in the bag. Question 3 then, find the area enclosed between the curve y equals 8x cubed, the x-axis, and the line x equals 2. Well, that's the integral between 2 and 0 of 8x cubed with respect to x, which is add 1 to the power, divide by the new power, put a 2 in, put a 0 through, take them off each other, and you end up with 32 units squared. Obviously when you put a 0 into that, it dies, so we'll just put the 2 in and call it 32 units squared. Hence or otherwise, deduce the area between the x-axis, the y-axis, the line x equals 2, and the curve y equals 8x cubed plus 5. Well, all you're doing there is doing the same integral with another 5 on. So isn't that just that? Stick a 2 in, stick a 0 in, take them off each other, you end up with that, which is 42 units squared. You're just adding on a 10 there. Question 4 then, a train travels from station A to station B. It starts from rest at A and comes to rest again at B. The displacement of the train from A at time t seconds after starting from A is s meters, where s equals 0.09 t squared minus 0.0001 t cubed. Find the velocity at time t after t seconds after leaving A, and hence find the time taken to reach B. Give the units of your answer. So, relationship between displacement and velocity is through differentiation. So we have to ds dt it, and we end up with that. Power to the front, knock 1 off the power, and then that is your velocity, and we know that it gets to 0 again once it's reached the point B, because it says it comes to rest again at B. So we'll set our velocity function equal to 0, t's a t out, and you end up with that. Therefore t equals 0 or 600, because 0.18 divided by 0.0003 is 600, or 60 minutes, no sorry, not 60 minutes, it would be 10 minutes, 600 seconds, and a sixth of an hour if you like as well. So you obviously have to say seconds for the units. Part 2. Find the distance between A and B. Give the units of your answer. So When t equals 600, s equals 10,800 meters. That's pretty much it for that question. Obviously when it's 0, s is 0, so obviously after 600 seconds you let t equals 600, you get 10,800. It's 10.8 kilometers if you like that unit of measurement, or whatever, however many centimeters it is as well. But yeah, not too bad a question, that one. Question 4. Question 5 then. A ship is moving on a bearing of 0.25 at 14 knots, where 1 knot equals 1 nautical mile per hour. As it passes point A, a lighthouse L is seen on a bearing of 340 degrees. And after 30 minutes, the ship passes a point B, from where the lighthouse is seen on a bearing of 320 degrees. So, find the angle BAL and the angle ALB. So, we'll start with BAL, which is 360 minus 340. BAL, by the way, is BAL, so that's this angle here. So 360 minus 340, because obviously we have what we're reading here. From the point A, a lighthouse is seen on a bearing of 340. So we know that this whole angle here is 360, and we know that's at a bearing of 340. So we take them off each other, and we end up with 20, and obviously 20 add 25 is equal to 45. Where I got the 25 from was this here. That there is 25, and we know that the bearing here from north all the way to here, that is 340. So I shouldn't. I might just draw this again just to make it clear. So erase all ink on slide, because I think it's worth you guys seeing. So this angle round the outside like that, that is 340, and that there, this one here, so if I put another line here, I'm going to call that X, that is 25 degrees. And we're trying to find out the whole of this angle here. So 360 minus 340 for this little angle here, which is 20, and then add that to your 25. My cat is coughing over there, so you can probably hear that. I might just quickly stop the recording. Sorry about that, guys. Right, sorry about that, guys. Cat was just having a bit of a coughing fit, so I thought I'd save it. But yeah, there you go. So the whole angle BAL is 45, because obviously 20 at 45 is 45. Right then, and now we want the angle ALB. So if we start at A, we go to L and B, so that is that angle here. So ALB must be 320 minus 180 plus 25. Now the way I got that is by reading the next bit. So here, so the whole angle round here, whoopsie daisies, the whole angle round there, that is 320 degrees, because it's obviously with respect to L. So this angle here must be 320. No, sorry, not that angle there. I don't know what I'm talking about here, do I? Really? Let's get rid of that. The angle here, I'm going to call X. Might do this in a different colour actually. We'll do it in blue. So this angle here is obviously going to be 180, which is this here, and the 25, which is this here, added together and took off the 320, which is the whole thing, all the way around here. Right, so that's where I got that from. There's probably an easier way to do this, thinking of it, but you know, hey ho. So that's 115, that angle there, which we called X. And obviously angles in triangle, 180, so it's 180 minus your 45 from before, minus your 115, so that equals 20 degrees. Bit of a difficult question to start off, and only 3 marks for all that work, but I hate bearings myself, so you know, I may not have done that the most efficient way possible. Then II is hence or otherwise calculate the distance BL in nautical miles, and just to aid with this, I am going to erase all the ink on the slide. So BL at 14 knots per hour, because it told us here. That means 7 knots in 30 minutes, and we're told that it's at the point B in 30 minutes. So it's obviously travelled 7 knots in 30 minutes. Therefore, AB equals 7, because remember 1 nautical mile per hour is 1 knot, so we'll call that 7. And then just use the sine rule. So we've got some angles there. So 7 over sine 20, because remember this angle here is 20, equals BL over sine 45, because remember this angle here is 45, which cross multiply, you end up with that. Put it in your calculator, you get BL equal 14.5 nautical miles. So not too bad once you get the nuts and bolts of the question in the end there. Question 6 then, the function f of x equals x cubed minus 4x squared plus ax plus b is such that x equals 3 is a root of the equation f of x equals 0. When f of x is divided by x minus 1, there's a remainder of 4. So stick a 3 through and we know that equals 0. Stick a 1 through and we know it's going to be equal to 4. So a plus b must equal 7. 3a plus b must equal 9. Take top from bottom and we end up with 2a equals 2. Therefore a must equal 1. Shove it back through, your b's a 6. So not too bad for the first bit. And now we're asked to solve the equation f of x equals 0. So we divide x minus 3 into our new cubic with the a's and b's in, because 3 is a root, therefore x minus 3 is a factor. Divide that in and we'll get a quadratic on the top of x squared minus x plus 2. So just do that in your own spare time. If you don't know how to divide polynomials, there's a lesson on the channel. Factorise that quadratic that you've just got and you end up with that. So x equals 3 minus 1 or 2. So there you go. Question 7. The points A and B have coordinates 3, 7 and 5, 11 respectively. Find the exact length of AB. So it's back take back squared added to front take front squared and rooted. If you don't understand that, there's also a lesson on the channel, which is that root 20 or 2 root 5. And when it says exact, that means leave it in surd form, fractional form, any form which doesn't involve recurrent decimals or any sort of decimals. It should always be a root or a fraction. Find the equation of the circle with diameter AB. So if we know the diameter is that, well, we need the midpoint first, because the centre of a circle is the centre of the diameter, which is otherwise known as the midpoint. So we'll find the midpoint, 4, 9. Just doing the average of the x's, average of the y's. And if we know that the diameter is 2 root 5, the radius must be root 5, because the radius is half the diameter. Putting all the information into the circle's equation. So remember, we reverse park the numbers into the slots. So it's a minus 4 in the brackets, a minus 9 in the brackets, and we square up our radius. So root 5 squared is 5. So that's that. Question 8 then. 4 points have coordinates A, B, C and D. Using gradients of line, prove that ABCD is a parallelogram. So the grad of AB is back take back over front take front, which is 4 minus minus 1 over 0 minus minus 5, which is 1. Grad of CD is also 1. Grad of BC is minus a 7th. And grad AD is minus a 7th as well. 2 pairs of parallel lines, therefore it's a parallelogram. That's the very definition of what a parallelogram is. Using length of lines, prove further that ABCD is a rhombus. So we're going to have to look at the length. The length of AB is 5 root 2. The length of BC is 5 root 2. And because these lines are parallel, and these lines are parallel, and if you picture this, so we've got that, so that is A, B, and we'll call that BC. So if them two are parallel and equal in length, that means these two must be parallel and equal in length therefore it is a rhombus. Equal side lengths, therefore a rhombus. You could further prove it by testing all the points for length and call them 5 root 2, and then saying they're all equal, therefore it's a rhombus. But there you go. And prove that it's not a square. Well, 1 does not equal 7, therefore the gradients are not negative reciprocals of each other, therefore they're not perpendicular, therefore it must not be a square. So 6 marks I think is a little bit harsh on this question. It could have been worth more, but hey yo. Question 9 then, show that 1 minus cos squared x over 1 minus sine squared x equals tan squared x. So 1 minus cos squared x over 1 minus sine squared x can be replaced with sine squared x over cos squared x, because remember, the big one here, sine squared x plus cos squared x, and you must learn this by the way, equals 1. So we can manipulate this to get with sine squared on its own, which is up here, and with cos squared on its own, which is down here. Obviously you'd shunt him over the other side for cos squared, you'd end up with 1 minus, he gets cos squared equals 1 minus sine squared, which is this here, so that's where that comes from. But remember, a sin over cos is a tan, so therefore sin squared x over cos squared x equals tan squared x. Hence solve the equation 1 minus cos squared x over 1 minus sine squared x equals 3 minus 2 tan x for the values of x in the range 0 to 180. Well, we've just worked out that this equals tan x, so therefore we can replace this with a tan squared x, which is what I've done. And we'll set that equal to 3 minus 2 tan x. Taking people over the other side, you end up with that equal to 0. That is a quadratic in t. Factorise that to get that. So therefore your tan x must equal minus 3 or 1. Get your calculator involved, you get 108.4 or 45. For this value here, you will get a negative answer, but remember it's in the range 0 to 180, and tan solutions come every 180 degrees. Question 10 then, find the coordinates of the point P on the curve y equals 2x squared plus x minus 5, where the gradient of the curve is 5. So dy dx in its purest sense is a gradient finder. We have been told the gradient in this case, so we can set our dy dx equal to 5. Take a 1 over, we get 4x equals 4, therefore x is a 1. Put your x back through the equation to work out your y, and you get minus 2. Therefore the point P is 1, minus 2. Part 2 then, find the equation of the normal to the curve at the point P. And I think that may be a smoke alarm, but we'll continue anyway. Start, so I'll finish. Find the equation of the normal to the curve at the point P. Well, we know the gradient of the tangent is 5. Therefore, the gradient of the normal must be negative a fifth at the point minus 2, sorry. Then y minus b equals mx minus a. Shove in the numbers. Times through by 5 because I hate fractions, and I get that. And then I would like my x's to be positive, so I'll bring everybody over that side. Call it 5y plus x plus 9 equals 0, but anything after this point, once you've tidied the numbers up, is acceptable. Question 11 then. Carla is making an open box out of a rectangular piece of card measuring 30 centimeters by 14 centimeters. She cuts squares of side x centimeters out of each corner and turns up the sides to form the box. So find an expression in terms of x for the volume of the box and show that this reduces to v equals that. Well, your length is 30 minus 2x because obviously that's x and that's x. So the whole length must be 30 minus 2x. Your width is 14 minus 2x via the same principles. And your height is x because obviously when it's folded up it's going to be a height of x. And you find volume by doing length by width by height. So you times them all together, you get that. Expand the brackets and you get that. Expand again and you get that, which is what the examiner wanted you to get. Fair enough, it's in a little bit of a different form, but you can switcheroo that round, and and get what the examiner had. So 4 marks there. Part 2, find the values of x that give dv dx equals 0. And then that's where you ask yourself, well, hold on, I've only been taught about dy dx. What's this dv dx? Well, I didn't tell you at the time, but dy dx is actually the change in y over change in x. Really, it's delta y over delta x, which is why it's the gradient finder. So dv dx must be the change in v with respect to x. So it's literally just d left, d right, because if it was y equals 420x minus 88x squared, you just bring the power to the front, knock 1 off the power. So we do dv dx, the change in v with respect to x. So power to the front, knock 1 off the power, same principles apply, and when it's set equal to 0, you do that. So your common factor of 4 there, so I do that, and that, amazingly enough, does actually factorise to that. Don't spend your time looking for factorising pairs in the exam, unless you know a clever trick to do it. Quadratic equation, you'll get exactly the same answer as 35 over 3 or 3. And then explain why one of these values should be rejected and find the maximum value of the box using the other value. So, I didn't get this, but I looked on the mark scheme. 35 over 3 is greater than half of 14. So that's why you reject that value. And using the other value, when x equals 3, you stick it back through your volume equation here, and you end up with 576 once you've worked it out. Question 12 then. Paul walked from any town to next town a distance of 15 kilometres. When he got there, he then walked back. His average speed on the return journey was 2 kilometres per hour less than on the outward journey. So let Paul's average speed on the outward journey be x kilometres an hour. So the time there is 15 over x, because he was going 15 kilometres, and that's what you get, 15 over x. And the time back must be 15 over x minus 2, because obviously it goes 2 kilometres per hour less than on the outward journey. So that's part 1 done. The time taken by Paul for the whole journey was 6 hours. So we set up this equal to 6, so it's his time there added to his time back, and that's equal to 6 hours. Times throughout by x minus 2, so you get that. Expand, and you get that. Take people over the other side, and you eventually get that. I see common factor of 6, so I'll call it that. And that is what the examiner told you to get. Part 3, solve this equation to find Paul's average speed on his outward journey. So that doesn't factorise, we have to use a quadratic equation. And we get that, which is that. And then we shove that back into our equation, and we get 6.19 kilometres per hour. Find the difference in time between the outward and return journeys. Give your answer to the nearest minute. So that's that. Obviously, that is that. X minus 2 is that. That should be a minus there, because it's the difference. And when you put that in your calculator, you end up with 1.16 hours. But we're meant to give it to the nearest minute, so we call it 70 minutes. So there you go. Question 13 then. A company needs to buy some storage units. There's 2 types of unit available, X and Y. The cost of each type of unit, the floor space required, and the volume of storage are given in the following table. Best way to get linear programming this. I'll let you read the other bits of the thing if you want to pause it now, but we're going to go straight to write down inequality for the total cost and an inequality for the total floor space required. So working down the column, you get 100 x plus 120y must be less than or equal to 1200, and 2 x add 1.5y is less than or equal to 18, using this column here, and 18 meters squared. And drawing that on a graph, you end up with that. Shade the areas you don't require. And then write down the objective function for the volume for storage and find the combination of units that should be bought to maximise the volume for storage. Write down this maximum value. So this is the information we use. We get that, and that's equal to P. Let 3x plus 3.5y equal 21, a nice friendly number. Therefore your x equals 7, your y equals 6 using the cover-up method. Draw that on like that. Max at 6,4 when you go in a parallel fashion. So you end up with that. And then you put that back through your objective function to get 33. So not too bad at all. Question 14 then. Mugs are packed in boxes of 10. On average, 5% of the mugs are imperfect. A box of mugs is classified as unsatisfactory if it contains 2 or more imperfect mugs. State 2 conditions that must be satisfied for the number of imperfect mugs in a box to have a binomial distribution. Well, if you watched the lesson on it, I went through points that you must learn and what makes it a binomial. Basically, it's a constant probability of success and each event is independent of each other. Pardon me. Assuming that these 2 conditions are satisfied, calculate the probability that a box chosen at random is unsatisfactory. So x can be binomially distributed 10, 0.05. P of x is greater than or equal to 2 equals 1 minus the p of x is less than or equal to 1, which is 1 minus p of x equals 0, add the p of x equals 1, which is that. 10c 0 times success to the 0 times failure to the rest, which is that, which is that. So that is 6 marks, and a well-earned 6 marks as well, I might add. Now, the last part of the paper, very last question, a lot to get your head around. A shop receives a delivery of a large number of boxes of mugs. The delivery is checked as follows. A box is chosen at random. If there's no imperfect mugs in the box, then the whole delivery is accepted. If the box is unsatisfactory, then the whole delivery is rejected. If there's exactly 1 imperfect mug in the box, then a second box is chosen at random. The delivery is accepted only if the box contains no imperfect mugs. Calculate the probability that the delivery is accepted. So the p of accept is the p of x equals 0, because obviously this is this part here, no imperfect mugs, or an ON probability is plus. The p of x equals 1, because it's going to be 1 the first time, times it's, and then because and in probability is times, so it's 1 and the next box has none in, so you end up with p of x equals 0, which is that. And then add them together and you get the probability of him accepting a delivery is 0.7874. And that is that for the June 2014 paper. I hope you guys have found this helpful. Please leave a like down below if you did. Obviously leave your feedback down below as well, and let us know how you're getting on with the FSMQ. Let us know how the mic quality is. Obviously it's probably not perfect for the first time, but obviously I can fiddle around with settings and stuff. And we've got 2 more papers to go in this series. The 2015 paper, so last year's paper, and of course the specimen paper as well, which is okay in terms of quality but not great, but we'll do it anyway. A little bit of extra practice for you guys. So yeah, let us know how you're getting on, and yeah, thanks for watching and goodbye.